Hello students, welcome to my channel part3. Dear students, in my last video I have discussed with you all this vector analysis I have divided into three parts. First part was consisting the type of vector, the four type of vector right? That is unit vector, null vector, like vector and opposite vector. And then the properties of addition of two vectors, right? And very important formula at that time must have discussed that r is equal to under root a square plus b square plus 2ab cos theta. What is that? If the two vectors, vector a and vector b, are making an angle theta with each other, then their resultant r will be equal to the under root a square plus b square plus 2ab cos theta. After that comes subtraction of two vectors. I have told you all that subtraction is not a special case. Actually, there is no different method used for the subtraction in vector analysis. Subtraction is a kind of addition. Like you have to subtract the two vectors, vector A and vector B, right? A minus vector B means you are subtracting vector B from vector A. Then you might can write like this: A plus minus vector B means you are adding opposite vector of vector B in vector A. That is equal to A minus B. Means subtracting the two vectors means just adding the opposite of one vector to other vector, right? So subtraction is also a case of addition. It is a type of addition in vector analysis. And then it comes the multiplication of two vectors. I have told you that if they are the scalars, like the two scalar quantities have the magnitude 6 and 5, then if you multiply them, 6 5 is 30, right? Or 5 6 is 30. So answer is 30. There's no change at all. But in case of vector, dear students, there is two type of products. One is called scalar or dot product, and another is called vector or cross product. The two vectors are like vector A and vector B, right? Then their dot product or scalar product is written as vector A dot vector B is equal to AB cos theta, where this is a vector A and this is the vector B and this is the angle theta between them. What I have said that A dot B is equal to AB cos theta, right? Where theta is the angle between them. Dear students, why it is called dot product or scalar product? Because the resultant of dot product of two vectors result into a scalar quantity. I have given you example. A is a scalar, B is a scalar, cos theta is a scalar. That is why A dot B has a scalar result. That is why it is called scalar product. For example, I have told you our work W is equal to F dot S. Force and displacement are vector quantities and their dot product result into work, which is work is energy, and every kind of energy is a scalar quantity. So, dear student, W is equal to F dot S. But today's topic is not. In last video, I have discussed with you all these things. Today's topic is we have to discuss cross product and its properties. Today's topic is a cross product and its properties. Let the two vectors are vector A and vector B, right? Their cross product is written as vector A cross vector B, that is equal to AB sin theta n cap. Dear student, cross product is also called vector product. Why? Because the result of cross product of two vectors result into a vector quantity. Undoubtedly, A is a scalar, B is a scalar, sin theta is a scalar, but here is a n cap. It's important. You have to apply n cap. N cap is a unit vector, right? It gives you the direction of vector A cross vector B. Where n cap is what? N cap is a unit vector. It gives you the direction of vector A cross vector B. Now, dear students, A cross B is equal to AB sine theta n cap. Now, the result of A cross B is a vector. That is why cross product is called to be the vector product. Now, because it is a vector A is a vector, vector B is a vector, vector A cross vector B is also a vector, right? So, undoubtedly it has the direction. Now, how will you find out the direction of vector A cross vector B? Very simply, let it is a vector A, right? And this is the vector B, and it is the angle theta. Dear students, if you have to find out the direction of vector A cross vector B, nothing you have to do. Just put your hands, your fingers along vector A. Now you have to find out the direction of vector A cross vector B. Now turn your this finger towards vector B, and this thumb represents the direction of vector A cross vector B. So it is a vector A, it is a vector B. I have put my fingers along the vector A and curl these fingers towards the vector B, and so this thumb means this. It is normally outward, representing the direction of vector A cross vector B. Now what happens if you have to find out the vector B cross vector A? Then in that case, these fingers should be along vector B, and now curl B cross A. You have to find out, curl these fingers towards vector A like this, and now your thumb is inward, normally inward. In that way, the direction of B cross A is normally inward, perpendicular to the whiteboard. So now, dear students, very interesting. When we were studying the dot product, A dot B is equal to B dot A. It means dot product was commutative, right? A dot B is equal to B dot A. But cross product is not commutative. Just you have find out A cross B is, the direction of A cross B is normally outward, whereas the direction of B cross A is normally inward. The angle between A cross B and B cross A is what? 180 degree. A cross B is like this, and B cross A is normally inward. This is A cross B, this is the B cross A. So the angle between A cross B and B cross A is 180 degree. Now dear students, you might write A cross B is equal to, is not equal to B cross A, or you can write A cross B is equal to minus B cross A. The two are the opposite vectors, right? Now, dear students, you say A cross B is equal to AB sine theta n cap, where n cap is what? It is a unit vector representing the direction of A cross B. Unit vector is a what? A vector which has the magnitude unit. It represents, it gives only the direction. In that case, n cap suffix A cross B means n cap is the direction of A cross B, is a unit vector, has the magnitude 1 representing the direction of A cross B. Now that is equal to vector A cross vector B upon A B sin theta. So much results we will discuss with these formulas. Now let's move. Dear students, some very important thing we have to discuss, like very general thing. Let a vector A is a A1 I cap plus A2 J cap plus A3 K cap, simply. Now, dear students, vector A is equal to A1 I cap plus A2 J cap plus A3 K cap. What does mean to this? If a physical quantity is represented in terms of I cap, J cap and K cap, then undoubtedly it is a vector quantity. There is no need any further explanation. Now vector A is equal to A1 I cap plus A2 J cap plus A3 K cap. It means A is a vector quantity. Again and again I am repeating my words. Even in my last video I have emphasized on these words. Vector A A is a vector quantity which has the magnitude A1 along x-axis. I cap, j cap, k cap are the unit vector representing the directions of x, y and z axis. Now dear student, vector A is equal to A1 I cap plus A2 j cap plus A3 k cap, means A is a vector quantity which has the magnitude A1 along x-axis, magnitude A2 along y-axis and magnitude A3 along z-axis. Now let you have to find out the magnitude of vector A. Magnitude of vector A, that is you write like under root coefficient of I cap is A1, that is A1 square, coefficient of j cap is A2. This sign you have to consider. If it would have been minus A2 j cap, then you have to write here minus A2 square, and that becomes ultimately A2 square plus A3 square. This is the magnitude of vector A. Now can you imagine that from where this formula is derived? You say like it is a vector A. Suppose it is a vector A, right? So this arrow is what? This arrow representing the direction. Now what is the magnitude? Length of this vector. Length of this vector is representing actually the magnitude. So it is, let vector A is equal to A1 I cap plus A2 j cap plus A3 k cap. Suppose this is your origin, it is your vector A, and A1, this point P is the position vector, you can say. It is a position vector of your vector. This is the point A1 comma A2 comma A3. You might write like this, right? Vector A is equal to A1 I cap plus A2 j cap plus A3 k cap. Then vector A is what? It is the origin. I have drawn a vector A, means its head is being represented by these three, by this coordinate A1 cap comma A2 cap comma A3 cap. Dear students, origin is what? That is 0 comma 0 comma 0. Now the distance between the 2 points, you know the formula, that is under root x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square. I have said that what is the magnitude of vector A? That is this length from origin to point P, from origin to its head. Now dear student, this is 0 comma 0 comma 0 and this is A1 comma A2 comma A3. The distance OP is the actually the magnitude of vector A, and that works out to be mod of vector A is equal to root A1 square plus A2 square plus A3 square. Now look here, dear student, vector A means A is a vector quantity. It has the magnitude as well as the direction. Now what I want to do, that I want to write the two things separate, that magnitude and vector, and is a vector. Both can you write separately? Yes. Vector A, that is equal to mod of vector A. Mod of vector A means A is a vector quantity undoubtedly, but we are concerned only with the magnitude. Means here it is a magnitude of vector A. Now for the direction, further I am writing n cap. N cap is a unit vector which is representing the direction. Dear students, again I am repeating my words. Vector A, sorry. Vector A is equal to mod of vector A into n cap. Means A is a vector quantity. It has the magnitude and direction both. So separately I am writing the magnitude like this, mod of vector A into direction, that is n cap, and so it becomes n cap is equal to vector A upon mod of vector A. Right? So in this case you can write the n cap unit vector of vector A. That how you can write? That is a vector A is this much, A1 I cap plus A2 j cap plus A3 k cap, right? Upon mod of vector A is this. In this way you find the unit vector of vector A. Dear students, actually I have to discuss with you all the cross product, but going into this topic at length, at a glance, I am discussing just the basics of vector. Now, dear students, you find n type unit vector of vector A. Now question, I'm giving you a question, very simple question. Just you find the n cap unit vector of vector A, that is a1 I cap plus a2 j cap plus a3 k cap, right? Divided by this under root a1 square plus a2 square plus a3 square. Now dear students, the question is that find out another vector which has the magnitude double of vector A but oppositely directed. Question is that you have to find out another vector, right? Let that vector is vector C, which has the magnitude twice of vector A. Means magnitude is a twice of mod of vector A, but it is oppositely directed to vector A. Means Na cap, this is unit vector of vector A. It is giving the direction of vector A, but the new vector C is oppositely directed to vector A, right? So you have to take minus Na cap. Na cap is a unit vector of vector A, but the question is saying that you find out another vector C which has the magnitude twice of vector A, but it is oppositely directed to vector A. So twice of vector A is given is a magnitude, and minus n cap is representing the direction of new vector C. So you just keep going. To mod of vector A is this under root a1 square plus a2 square plus a3 square minus n cap is this much, that is a1 I cap plus a2 j cap plus a3 k cap divided by under root, that is a1 square plus a2 square plus a3 square. Now if you solve, that is minus 2 into a1 I cap plus a2 j cap plus a3 k cap. This result you get. Means actually it is a 2 time of vector A but oppositely directed, so I have written negative in front of vector A. This is the value of vector C. Now dear students, what we are going to discuss, that cross product of two vectors. Just I said, let the two vectors are vector A and vector B. Their cross product will be A, B sin theta n cap. N cap is a unit vector representing the direction of vector A and vector B. This again, if you go over the direction, let it is a vector A, it is the vector B. This angle between A and B is theta. If you want to find out the direction of vector A cross vector B, then just put your fingers along vector A. You have to find out the direction of vector A cross vector B. So curl your finger towards vector B. This thumb will represent the direction of A cross B. In this way, you will get the direction of A cross B normally outward to the plane formed by A and B. Actually, if you will see, this vector is perpendicular to vector A and perpendicular to vector B both. So you can say the direction of A cross B is perpendicular to the plane formed by A and B, and also perpendicular to vector A and perpendicular to vector B. Again I am repeating my verse. The direction of A cross B is perpendicular to the plane formed by vector A and vector B. Also it is perpendicular to vector A and perpendicular to vector B. Now dear student, A cross B is equal to AB sin theta n cap. In the same way I have told you that if you want to find out the direction of B cross A, just put your fingers across the vector B and curl towards vector A. This thumb, that is a perpendicular inward, perpendicular to the board inward, it will represent the direction of vector B cross vector A. In this way, vector A cross vector B is normally outward, whereas vector B cross vector A is normally inward. The direction between two is the angle between vector A cross vector B and vector B cross vector A is 180 degree. Actually, they are opposite to each other. I have told you that dot product is a commutative, means A dot B is equal to B dot A, but in case of vector product, it is not commutative. A cross B is not equal to B cross A, because A cross B and B cross A are the opposite vector. So the angle between the two, A cross B and vector B cross A, is 180 degree. Now dear student, A cross B is equal to AB sin theta n cap. N cap is the direction of vector A cross vector B, and the direction of vector A cross vector B is what? It is perpendicular to the plane formed by vector A and vector B, and also perpendicular to vector A and perpendicular to vector B separately. Now dear students, let's discuss its properties of cross product. First, if theta equals to 0, means if the two vectors are parallel to each other, then what happens? Sin 0 is 0, vector A cross vector B is equal to 0, right? Means if the cross product of two parallel vectors vanishes, right? The cross product of two parallel vectors vanishes. Now dear student, second is if theta equals to pi by 2. What happens if the two vectors are perpendicular to each other? Then what is the result of their cross product? Now look here, vector A cross vector B, that is equal to AB sin pi by 2 is 1, and that is n cap is equal to vector A cross vector B upon AB, right? AB means magnitude of A and B respectively. In this way, this is the unit vector of vector A cross vector B in the case when the two vectors are perpendicular to each other. Third property, let I cap comma j cap k cap are unit vectors representing x, y and z axis respectively. Dear student, now what happens? I cap cross I cap. Just you have got that the cross product of two parallel vector vanishes. A vector is always parallel with itself. A vector is always parallel with itself. I cap is parallel to I cap. In similar way, j cap is parallel to j cap. In similar way, k cap is parallel to k cap, and that is all vanishes. Right? The result of their cross product is 0. Dear student, but important is that what happened? I cap cross j cap. Now look here. This is I cap is along the x axis. J cap is along y axis. I cap cross j cap, that is along k cap. This result into the direction is, because I cap and j cap are the unit vectors, so the result will also be unit vector, but the direction of I cap cross j cap is towards z axis, that is towards k cap. In similar way, you can write j cap cross k cap. That is this is j cap cross k cap, right? This is j cap, and let this is k cap, right? So I'm turning towards. You have to make this. This is j cap and k cap is this. So j cap cross k cap. This is, my fingers are along y axis, and k cap is this. So for the j cap cross k cap, turn like this. This thumb is representing along x axis. So j cap cross k cap is a I cap. In similar way, k cap cross I cap, that gives you j cap. Right? You have to remember this. Simply you can write this I cap, k cap, j cap. I cap cross k cap equal to j cap, right? In the same way, this is in an order, in a clockwise order it is moving. I cap cross k cap equal to j cap, k cap cross j cap equal to I cap, j cap cross I cap equal to k cap. Right? In a clockwise we are moving. I cap cross k cap equal to j cap, k cap cross j cap equal to I cap cross k cap equal to j cap, in this way, right? I cap cross k cap equal to j cap, k cap cross j cap equal to I cap, j cap cross I cap equal to k cap. In this way we are moving. Now dear student, how will you find out? Next property is, let vector A is equal to a1 I cap plus a2 j cap plus a3 k cap, whereas vector B is equal to b1 I cap plus b2 j cap plus b3 k cap. Right? Now, question is that how will you find out A cross B? If vector A is this much and vector B is this much, you have to find out the A dot B. Then what you have to do? That coefficient of I cap is A1 here, coefficient of I cap is B1 here. You write A1 B1 plus coefficient of j cap in both the vector you multiply, then coefficient of k cap you multiply, and ultimately you add with sign. This is the result of A dot B. Why it is so? Because if you consider A dot B, then I dot I cap is 1, but I dot j cap is 0, I dot k cap is 0. That is why you consider only the coefficient I cap. Similarly, j dot I cap is 0, j dot j cap is 1. That is why you consider A2 B2, and j dot k cap is also 0. Now, if you consider A3 k cap, then k cap dot I cap is 0, k cap dot j cap is 0. Now k cap dot k cap is 1. That is why you do consider A3 B3. Means in case of dot product, you consider only the coefficient of I cap, j cap and k cap in both the vector, and ultimately you add this sign. This is the result of A dot B. But in A cross B it is not so, right? You have to make the matrix like this. You have to find out A cross B, right? A cross B. How will you find out? Dear students, I am writing here I cap, j cap, k cap. Now, vector A cross vector B you are considering. So, write down the coefficient of vector A. In vector A, coefficient of I cap is A1, coefficient of j cap is A2, coefficient of k cap is A3. Now, cross vector B. In vector B, coefficient of I cap is B1, coefficient of j cap is B2, and coefficient of k cap is B3. Now, you can write like this. Here write I cap. Now ds will drop this. Now A2 B3, A2 is multiply this A2 B3 minus A3 B2. Now write here negative, plus minus plus. In this order is moving. I have written here minus. Now considering j cap, just forget this. A1 multiplied with this, right? A1 B3 minus A3 B1 plus, finally I am writing for k cap. Drop this. Now here plus minus plus, right? Alternative sign is considered. Plus k cap, drop this. This multiply A1 B2, diagonally multiplying A2 B1. This is the result of A cross B. In the case of A dot B, it's very simple. You just consider the coefficient of I cap, j cap, k cap, with sign, multiply and add them. But if you have to find A cross B, you have to make the determinant, and in this way you have to follow. That is why it is said that when you have to find out the angle between vector A and vector B, vector A and vector B are given in terms of I, j, k, and you have to find out the angle between A and B. Then dear student, very simple method that you should consider dot product at that time. But in some cases you have to consider the cross product. There is no options left. Like question might be asked like this, Look here. A question may be like this. Let the two vectors are vector A is equal to I cap plus j cap. Vector B is equal to j cap minus k cap. Right? The two vectors are vector A and vector B given. Find out another vector which is perpendicular to vector A and vector B both and have the magnitude 2. Now question is that problem is vector A is equal to I cap plus j cap and vector B is equal to j cap minus k cap. Question is saying that find another vector which is perpendicular to both vector A and vector B. This is perpendicular to both vector A and vector B and has the magnitude 2. And has the magnitude 2. Question is saying that the two vectors vector A and vector B are given in terms of I, j, k. Now, question is saying that find another vector which is perpendicular to both A and B and has the magnitude 2. Correct? Find a new vector which is perpendicular to A and B and has the magnitude 2. How I'm writing the solution? Let's do. Let a new vector is vector C, right? Now, dear student, vector C is equal to, I'm writing, its magnitude is mod of vector C and its direction is NC chi, right? I have written separately the magnitude as well as direction of vector C. Now, dear student, it is saying the new vector has the magnitude 2. So, nothing you have to do. Now, NC cap, unit vector of vector C. It is saying that the vector C is perpendicular to both A and B. Means it is, now this is vector A, this is vector B. Let the angle between them is theta. I have told you initially that A cross B has the direction perpendicular to the plane formed by vector A and vector B. The direction of vector A cross vector B is what? That is perpendicular to the plane formed by vector A and vector B. And it is perpendicular, not only perpendicular to the plane formed by vector A and vector B, but it is perpendicular to vector A and vector B separately as well. Now, dear student, it means the direction of vector C is a direction of A cross B. Means what you have to do, unit vector. What you have to do, you have to find out the unit vector of this A cross B, right? So, A is this, B is this. How will you find out A cross B? How you can find out A cross B, dear student? Look here. A cross B is equal to I'm writing like this, I cap, j cap, k cap. Vector A has the coefficient 1, 1, 0. K cap is absent here. Vector B has the coefficient I cap is absent, so it is 0, 1, minus 1. Now solve it. Writing here I cap. Dear student, 1 into minus 1, that is minus 1, minus 0 into 1, 0. Again plus, then minus. Here writing for the j cap. Drop this, 1 multiplied by minus 1, that is minus 1. Minus 0 multiplied by 0, that is 0. Plus, minus, then plus. Here for the k cap I am writing. Drop this, diagonally multiply, 1, 1 ja 1, minus 1 into 0, 0. So you will get minus I cap, minus my plus j cap, and this is plus k cap. In this way, you have find out this is the value of A cross B, right? This is the value of A cross B. What you have to find out? Unit vector of A cross B. And unit vector, for example, it is a vector A. What is the, you write this like this, mod of vector into n cap, separately if you write. means n cap is equal to its unit vector is equal to vector A divided by its magnitude. In similar way, the unit vector of A cross B will be what? And the question is that what will be the unit vector of vector A cross vector B? That is vector A cross vector B divided by its magnitude. Nothing else. A cross B is a minus I cap plus J cap plus K cap. And its magnitude is a under root minus 1 is square 1, 1 is square 1 plus 1 is square, this is square root 3. Now dear students, the answer becomes here C cap, vector C, our new vector will be, has the magnitude 2 and its direction is perpendicular to A and B both. So which vector is perpendicular to A and B both? It is A cross B. So unit vector of vector C is what? That is a unit vector of A cross B, and unit vector of A cross B I have find here, that is minus I cap plus J cap plus K cap divided by square root 3. Question might be like this. Find out another vector which has the magnitude 2 and it is oppositely directed, right, to vector A cross vector B. Then in that case you have to consider here minus n cap A cross B. The answer you will get. Now dear student, again I am repeating, I am just going back. Let the two vectors are vector A and vector B. Dear student, if somebody asks that what does A dot B represents, there is no answer at all. Genuinely, really I am speaking, if somebody says that what does A dot B represents? Nothing. It is not a vector quantity. It is a scalar quantity. You cannot see it by diagram. Only if particularly the two quantities are given like force and displacement, their dot product is a what? Only then you can define. But in case of vector A and vector B, now discuss vector A cross vector B. What does it represent? Let it is a vector A and this is the vector B. Right? Angle between them is theta. Then what vector A cross vector B represent? Actually, it is the area parallelogram. This is mod of A cross B is equal to area parallelogram formed by vector A and vector B. Dear student, A cross mod of A cross B, you know, displacement is a vector quantity, area is a vector quantity, yet volume is a scalar quantity. Now question is that the two vectors are A and vector B. The angle between them is theta. Then what does vector A cross vector B represent? Dear student, vector A cross vector B is actually the area covered between vector A and vector B, or you can say it is the area parallelogram formed by vector A and vector B. Mod of vector A cross vector B is the area parallelogram formed by vector A and vector B. Now, it's a very important, this property has much to say than this. Like it is a vector A, it is a vector B, okay? First, let's start something else. Let vector A and vector C, they are coplanar. Suppose that the two vectors vector A and vector C are coplanar. What does it mean? Means they are directed in same direction. They have same direction. They might differ in magnitude like so. You can write vector A is equal to some fraction of vector C. You can write this. Or vector A might be 2 times of vector C, 3 times of vector C, 2.2 times of 4 times, 6.8 times, whatever, some fraction or integer might be. But there is a, if vector A and vector C is parallel, then there must a relation exist between vector A and vector C. If the two vectors vector A and vector C are parallel, then undoubtedly they have some relation. in their magnitude, yet they are directed in same direction. They are parallel. They are said to be coplanar, right? Or they are coplanar or collinear, right? They can be said coplanar or collinear, means in a line or parallel to each other. Dear student, now look here. What happens if vector and vector B becomes coplanar? Then if they becomes coplanar, either be bigger or smaller, their magnitude might be different. Vector A and vector B might have a different magnitude. It does not matter here. But if they are coplanar, collinear, they cannot form the parallelogram. In that case, mod of vector A cross vector B will be 0. It means if you have to prove that the two vectors, that given two vectors are parallel, coplanar, collinear, then their cross product, mod of their cross product should vanish. Only then if it happens, then you can say that the two vectors are collinear or coplanar. Dear students, this was the end of, I think it was the end of vector analysis. In 3 parts I have divided whole vectors. You can go through my videos. Dear student, least but not last, I tried my best to let you to explain. But if you have a problem regarding to my lecture, must comment. And please, if you do think that my videos are going to be beneficial to you, then please like, share and subscribe my video, and must put bell icon so that you might be notified about next video. Thank you.